Calculus kids, this is Dr. Callahan with week 14, Monday. I hope you guys had a good weekend. Let's go ahead and pause the video and take a look at the following 3 questions. All right, let's go ahead and get started. Last time I saw you guys, we went over a few things on concavity, and just keep in mind that if you ever need assistance with anything, there's with everything that I give you guys, there's always usually a link that's either to a video or to the answer itself. And so today we're going to continue on with our topic of concavity and the second derivative test. Our goals for this section is to determine the interval on which a function is concave up or down, and we're going to find any inflection points on the graph and apply the second derivative to try to find any relative extremas. All right, with that said, let's go ahead and take a look at the notes today. So this is the first page. If you need some additional practice, I do have some textbooks right here. These are my notes right there highlighted in yellow of concavity and the second derivative test as stated right here. So I would suggest you go over those examples on your own. The notes on the bottom will show you concave up and concave down, so you don't have to copy anything down. And then this is going to be our notes in class. I've typed up the steps for you guys as well, and we'll go over 2 different examples with it. And then we'll end the class with a calculus puzzle on how did the prison dentist help the inmate to go straight. All right, let's go ahead and get started with this. If you take a look over here, you don't have a ton of space to actually show the work, so you might actually want to write your answer on a separate piece of paper, which is fine, or on your desk, or whichever one is best for you. And just at the very end, take a look at the question right here. This is the free response question that dealt with concavity on the AP exam with one of their free responses. All right, let's go ahead and get started. All right, so looking at these 2 diagrams, are both of these functions increasing? And if you look at it, the answer is yes. Okay, and what do we know about the derivative? Well, the derivative essentially is just the rate of, it's basically just the rate of something. And of course, your slope is always changing. Now to go ahead and make sure that you guys understand the concept of concave up and concave down, this right here is a concave up. Similarly, this is a concave down. And so when it's concave up or down, how is that in relation to the slope? Well, the slope right here is becoming more positive, whereas if it is concave down, the slope is becoming more negative. Go ahead and read this part right here. Now, a point of inflection is going to be, if this is my diagram and I have something that looks like this, the point of inflection is going to be right here. Okay, it is that kind of turning point when something is going from concave down to concave up. And you will find that point of inflection by using the second derivative. And it is when the f double prime of x changes sign. All right, go ahead and take a look at the concavity test and read the steps. So the first thing to do is you're going to find the second derivative, set equal to 0. Find the critical points from both the numerator and denominator. You can set them both to 0. Put all the critical points on a sign line, and remember your sign line looks something like this. If you have 3 critical points, you'll go ahead and line them up right here. And then remember to test the slope, you will have to pick a point that's either on the left, in between, and the right side of your critical point. So it's always going to be f of x, f prime of x. So that way you can go ahead and test it. And then remember, if you do have a positive, negative for the first derivative, then what that indicates is that you want to draw your slope positive, negative, positive, negative. So at this point, it indicates a maximum. This point is a minimum. This point here is a maximum. So once you find the critical point, you can go ahead and test the intervals, plug the values in double prime of x to determine concavity. If it is a positive, it means concave up. If it's a negative, it means concave down. So if you have your critical points, you can actually go ahead and plug it in here as well. And actually, when you have your double f of x, this right here is not a critical point. It's a point of inflection. So when you go ahead and plug it in here, for the second derivative, it will be in the second derivative like this, okay? And then if on the left side, because you have 3 points, if on the left side you have a negative, let's say you have a positive, a negative, and a positive, what that means is that the concavity between negative infinity up to this point here is concave down. From this point to the next point, this is concave up. From the second point to the third point, it is concave down. And then from the third point on to positive infinity, it is now concave up. All right, so with that said, let's go ahead and maybe jump in and do an example. So looking at the first example right here, it is a fairly simple function. So let's find the concavity with a sign line with f double prime of x. So the first thing I do is I find f prime of x. So you just need to use the power rule. That is 2x to the 5th power, bring the 5 down. That's a negative 10x to the 4th power, plus 5/3 times 3 is just a 5x squared. So that is going to be your first derivative, okay? If I were to go ahead and find the max and min of this, I would just simply set this equal to 0. I can go ahead and factor out a, let's say, negative 5, and I can take out an x squared, which will give me a positive 2x squared minus 1 equals 0. And if you distribute it through, you should see that negative 5 times 2 is negative 10, x to the 4, negative 5 times negative 1 is positive 5, x squared. So then when I go ahead and set this equal to 0, I'm going to have x equals 0 from right here, because when you divide by negative 5 and you square root 0, it's still going to give you 0. And then from here, add the 1 and divide it by the 2. So x equals plus or minus the square root of 1 over 2. So then if I were to go ahead and find the max and min of this, I will have my sign line like this. And I will have 0 right here. And I will have negative square root of 1/2 here. And actually, I'm going to move my 0 over a little bit. There we go. So 0, and then positive square root of 1/2. So you have 3 critical points. And then what you're going to do is you're going to pick a number on the left side of this. So you can pick, let's say, to be on the safe side, negative 5. Okay, then f prime of, let's say, negative 0.1, and then f prime of positive 0.1, and then f prime of 5. Once you plug those in to f prime of x, you should have either a plus, minus, etc., and then you will find the maximum from that. Now, if it is a max or a min, and you want to find the y value, it will have 5, or excuse me, f of, excuse me, 0, comma, f of 0 to give you the actual location of the y value for the max and min. So you can go ahead and do that. But we're talking about concavity, so we'll just go ahead and continue on to concavity then. So then we're going to do f double prime of x, which is going to be negative 40x to the 3rd plus 10x equals 0. Okay, so then once I set it equal to 0, I'm going to go ahead and I would like to solve for x. So similarly to the first derivative, you can factor some things out. And as I'm looking at this, I could go ahead and take out a negative 10x, which will leave me with a negative 4x squared minus 1 equals 0. And of course, I just want to make sure that I get to the original equation before I proceed any further. And I notice that this should be a positive, not a negative. So that negative 10 times 4 gives me a negative 40, x to the third, negative 10 times negative 1, positive 10x, perfect. So when I solve for x, negative 10x equals 0 is going to give you just 0, because 0 divided by negative 10 is just going to be 0. Second part is you're going to go ahead and add the 1 divided by the 4, square root of that. So x is equal to positive or minus square root of 1 over 4, which is just going to be plus or minus 1 over 2. So 1/2. All right, so once I have this, I'm going to put this on a sign line, and I'm going to have my negative 0.5. I'm going to have 0, and then positive 0.5. Okay, so those are my 3 points. So then what I'm going to have to do is I'm going to have to pick a point that's in between the intervals here to test them in the second derivative. And I'm just going to pick f double prime of, on the left side of negative 0.5, I'm just going to do negative 1. In between, let's do 0.25 maybe, negative 0.25. And then in between 0 and 0.5, maybe a positive 0.25. And then on the far right side, you'll have f double prime of 1. So then once you have this, you want to go ahead and plug this into your graphing calculator in the graph section of this. So when you graph this, remember you're going to use the second calc and then value option. Second calc value option. And then you're going to type in the values of negative 1, negative 0.25, positive 0.25, and 1. And you should see that this right here is going to give you a positive number, a negative number, a positive number, and a negative number. So that means, and you can draw this, from negative infinity to negative 0.5, it is going to be a concave up. From negative 0.5 to 0, it is concave down. From 0 to positive 0.5, concave up. And then from positive 5 to positive infinity, it is a concave down. So then, of course, we have the write-up, okay? And you need to write up your justifications. And my justification is going to be as follows. I could say f double prime of x is concave up on negative infinity to negative 0.5, union 0 to half, because f double prime of x is greater than 0. The counterpart to that is f double prime of x is concave down on these intervals because f double prime of x is less than 0. And your last one, you should go ahead and say is that your point of inflection is at negative 0.5, negative 0.146. And the way that you get this part right here is that you have to plug in the negative 0.5 back into the original equation to find the y value. Okay, do the same thing with 0, you get the y value of 0. Do the same thing with positive 0.5, and you get a positive 1.146. Because f double prime of x changes signs at these points. And that's how you would do the first question. All right, let's go ahead and take a look at the second question. Before we do that, make sure you guys read the second derivative test in addition to the second derivative test steps. Okay, so let's go ahead and take a look at the second derivative test. So pretty simple, f of x. So if I were to go ahead and find f prime of x, I would have a 3x squared minus 8x minus 3 is equal to 0. Okay, once I have it this way, you will need to go ahead and ask yourself, how can I go ahead and factor this out? Depending on your Algebra 2 teachers, I was always taught 3x times x have to equal the first number, and then the second one, and I'm going to put a negative right here, has to equal the last number. But when I cross multiply, they have to equal the middle. So if I cross multiply here, 3x minus 3x, oops, that's not going to work because that gives me a 0x. And I want the middle term, which is a negative 8. So what does that mean? That means I need to go ahead and perhaps change the formation of the negative 3 and 3. So then let's say, for example, what if I put 3 here and a 1 here? I know my middle term is a negative 8, so that has to have the negative, because if I cross multiply this, negative 9x will be the bigger number. And so therefore, once I add them, that will have to carry over the negative sign to a negative 8x. So that works. So then what is my answer then? It's just going to simply go across. And if you do go across, you will have a 3x plus 1 and a x minus 3 equal to 0. Once I have this, I want to solve for x. My first x is a negative 1/3. Second x is a positive 3. That is going to be my point of inflection. So then with that point of inflection, I'm going to test it to see what the concavity is. I'm sorry, that's your critical point. Just kidding. Your critical point. If I were to test the critical points, I will go ahead and put them on a sign line. So if negative 0.33 is a negative 1/3, and then I have a positive 3. Then you're going to go ahead and pick a point that's on the left side of the negative 1/3. So let's just say negative 1. Okay, but put that in that first derivative, and then pick one in between. 0 will be great, and then f prime of 4, and then figure out whether it's a positive or a negative slope, and you make the determination whether it's max or min. And then once you do make that determination, and if you think that this is going to be a max, which I don't know at this point, but if it is, you are going to go ahead and say this is going to be a max, and my x value is negative 1/3. To find your y value, you just simply put that back into the original equation, and that will give you the y value, okay? But we're looking for the second derivative. So let's go ahead and continue on with this. With a second derivative, let's go ahead and do the derivative one more time. So I have a 6x, and just remember you're doing the derivative of this one here, minus 8 equals 0. Okay, so you're going to add the 8 on both sides. X equals a positive 8 over 6, which is the same thing as 4 over 3. So at this point, I'm going to do another sign line. And I am going to label it so that this part here is a positive 4 over 3. And of course, I'm going to go ahead and test this. So let's do f double prime of x. Left side of this, let's do 0. Right side of this, let's go ahead and do 2. If you plug this in here, f double prime of 0 is just going to give you could do this in your head. 6 times 0 is 0. 0 minus 8 is a negative 8, so that's going to be a negative. So you know it's a concave down. Same thing over here, 2. 6 times 2 is 12. 12 minus 8 is a 4. That's positive. So you know that's a positive, so that's a concave up. So then what you can go ahead and type and write about this is you could say something to the effect of um, you could say that the concavity of this oops, f double prime of x is concave up. It is concave up at um, 4/3 to positive infinity because f double prime of x is greater than 0. And I wish my pen would work, but it's not working right now. Okay, and similarly, you could say f double prime of x is concave down at negative infinity to 4/3 because f double prime of x is less than 0. And that's how you will go ahead and respond to that question right there. Now, if you were to go ahead and use a second derivative to test for max and min, if f double prime of x, when you plug in the critical point is less than 0, it's opposite, so use maximum. However, if f double prime of x with the critical point is greater than 0, then it's a minimum. So instead of doing the sign line like this is an alternative method that you can do this for. So if you look at this, f double prime of x equals 6x minus 8. So if you plug this in here for the negative 1/3, which is what you have here, you will find out it's less than 0. So that means opposite of a 0, less than 0 is going to be a positive relative max. So you can say relative max is at x equals negative 1/3 because f of negative 1/3 is equal to 0, and f double prime of negative 1/3 is less than 0. Similarly, you'll find your relative min at x equals 3 because when you go ahead and plug in f double prime of 3, it is greater than 0. All right, you guys, now what I would like you guys to try to do is take a look at this part right here for the AP College Board for response question. Now, specifically what I want you to do is type in this link right here. And from this link, you are going to be able to take a look at how the problem is graded. So if I click on here, you'll be able to see that as well. So this is what it is. Just like last time when I showed you guys one, this is how it is graded. So go ahead and take a look at the steps of how your peers will be able to answer this question. All right, guys, that's basically it. If you are done with this, I would suggest if you would like to practice, get started on the calculus puzzle, which is going to be on the very, very end right here. I hope you guys have a wonderful day, and as always, stay safe and healthy. Take care.